All right, so really quick reviewing from yesterday. What is in words? What is P hat C talking about? What is, if I ask you what is this, and you give me an answer in words, what would you say? What does this mean? The pooled or combined sample proportion. How do I find P hat? What is P hat C? Like, how do I find it? What goes on top? Divided by. When and why do we use it? So the justification I gave you yesterday, even though the book uses it all the time, and I get why what's the one that makes sense of why we use it? Why did we choose to put them together? Why did we not do it with interval? So why did we all of a sudden do it with tests? What's the whole basis of a test? What do we start with a test? So when we were claiming that they're the same, right? So we only do that when we are running a what? So do we make any claims about them with an interval? No. Alright, so I want to write the equation and we're going to rewrite it. So yesterday, when I'm dealing with tests, the bottom part of the equation is what?
P hat C, 1 minus P hat C.
Over
And
plus
same thing with
the orange sheet writes this different. And just because I'll forget if I don't say it right now, I want to tell you how it writes it. Algebra, what can I do there? I could square it. What's the same with both of those? So I could kind of go like undoing distributive property and rewrite it how? What distributes to both of them? The what part? The P hat C part, right? So I could rewrite it as taking this section out and pull it out to the front, which would make more sense to still leave it under the square root. They write it as we pulled this part out in front because it applies to both of them. So now what do I have left here? And that's what it looks like on your orange sheet. And I have people that all of a sudden look at that and they're like, wow, I've never seen this before. It's algebra. Most of you won't look at it. Most of you, it doesn't help at this point. You either know to use P hat C or you don't. But I just wanted to make sure that I make that point. All right, so we shouldn't have any issues basically jumping straight in today and getting started. Because we only use pooled when we were doing a test. We're not doing a test today, so we don't even have to worry about that. So when I'm doing a confidence interval for a 2-sample Z interval for difference in means, what's going to go up here? Not a hard part. Confidence interval, difference in means, what goes in the front? But I'm switching to today. So just switch them to means and it's what? X bar 1 minus X bar 2. So we're going ahead and writing the equations that that are going to be the ones for today. What comes right after that? Plus minus. Well, I told you this equation is going to be with z, so there's your z. So in general, this portion is the what portion of the equation? Standard deviation, standard error portion, whatever I call it. So when we are dealing with combined, so this is I want to combine these two things, right? So my two rules in combining are I have to switch them to all be what? So when I switch this to a variance, what does it actually look like? Right? And then sigma 2 squared over into. How do I have to combine them? And then right now they're a variance, but I don't want it as a variance, I want it as a what?
Standard.
So what's going to go here now that we just did that?
Sigma 1 squared
Over
n plus sigma 2 squared over n2.
So that's just using the idea of combining through variance. And you always add. That one is also on your orange sheet. So then my confidence interval equation when I'm dealing with t is x bar 1 minus x bar 2 going to change? No, that's still going to be x bar 1 minus x bar 2. Is this still going to be z? No, it's going to be t instead. And what's going to change over here? The sigmas become s's. From what we dealt with in the past with a one sample, now, is it usually overall reasonable to be given a standard deviation of the population and not know the mean? Not really that reasonable, like why would I know it? But with a one sample, it can be reasonable because I am comparing one group to the population, or I am seeing if the population is still what it used to be. But if I am starting with two brand new samples and I'm comparing them to each other, would it really be reasonable to have a standard deviation for the entire population in that situation? So this we don't use very much at all for two sample. We pretty much always use this because it just doesn't, there's not a time where it's reasonable, yeah.
Is that second S supposed to be S2?
Oh, yeah, 2. Yes, this is a 2. And that gets really funny. It's another reason I don't like using 1s and 2s. I like using subscript letters because squared with also having subscript 2s gets kind of messy. But you can still do it.